UW-Madison researchers would like to conduct research on how different groups of people drive using driving simulators. The main issue with gear shifters available on the market is that they focus too much on the gaming experience. Researchers would like to simulate a more realistic experience. Therefore, our product aims to combat that issue by simulating an automatic gear shift. Our solution involves a potentiometer to correlate points of rotation of the handle with park, neutral, drive, and reverse. The ball and door catch will mimic the actual locking of the gear shift, helping the driver determine when they have switched positions. Furthermore, our device is portable, allowing for off-site testing to be done. It also follows federal regulations for the neutral position to be in between drive and reverse.
So we built a box that allowed us to have some wiggle room for any bumps in the road that we might hit or any changes we might need to make. The next step was then building the extension of the enclosure for the buttons and the rotary encoder to be placed upon. And in the design of that, it was determining how high above the shaft of the shifter we wanted those to sit so that they were not interfered by the shifter at all, as well as how far back we wanted them to be so that they were still accessible but not too close to the shifter that it would once again be interfering. The last and most difficult part was most definitely figuring out the locking mechanism and how that was all going to fit in there, connect to the shifter shaft, the locking plate, as well as the potentiometer. And our final design ended up having an arc cut that a stabilizing screw was attached through the shaft and the plate that it could slide along to give the shifter more stability as it moved from one position to the next, as well as a machine screw at the axis point of rotation that was then JB welded to the potentiometer, as well as going through the shaft so that all of those move in tandem with one another. In order to determine the actual locking feel within the gear shifter, we used a rolling door catch. We took a router piece and cut slits along the positioning that we decided that we wanted the shifter to be in so that it moved the desired distance at the top of the shaft between positions. Then we connected everything together and it locks into place into each one and rolls past to the next stopping point, giving you that locking feel.
We fabricated our first prototype using scrap wood in the makerspace. This gave us a good idea of the general size and shape that we wanted. Using Onshape, I created designs for 3D printing. While our original design was more of a spherical oval shape, we decided to switch to a cylinder shape, as our knob no longer needed a button and it was also more comfortable for a wider variety of people.
So the circuit for the Gearshifter project used a laptop or computer as the power source running through an Arduino Leonardo. The Arduino Leonardo is hooked up to 4 buttons, a rotary encoder with a switch, and a potentiometer. Each of these will be used as controller inputs for our driving simulator. I utilized the Arduino joystick library that allows buttons to be easily mapped to different inputs on Arduino pins. I was able to set different values for the potentiometer. When it's at different positions, the resistance will change, and each different level of resistance can be set as a button. So that is how we achieved the park, reverse, neutral, drive gear shift. In order to fabricate the circuit, I connected the button wiring to smaller jumper cables that work with the breadboard and Arduino Leonardo by soldering the connections together. I did that for 4 buttons, and then I used the rotary encoder and potentiometer and attached wires to each of them. To the rotary encoder, I used just socket wires and attached them and hot glued them in place so they would remain there. And for the potentiometer, I soldered 3 separate wires to the pins because the pins did not fit very well with the traditional jumper cables the makerspace has available. And then I used heat shrink tubing to secure the connection.